called starts with a D, discriminant. So the discriminant is b squared minus 4ac. That tells you a lot of information with quadratics when you're using the quadratic formula, whether or not you will have no real answers, one real answer, or two real answers. So most of you probably got two answers. And if they had i's in them, then that means you had two complex answers, which means they're not real, which means I can't graph them. If I were graphing, I couldn't graph them on an XY coordinate plane. I'd have to graph them on a real imaginary coordinate plane, and yes, those do exist. So quadratic formula is one of the surefire ways to solve a quadratic. The other one is what we're going to do today also, completing the square. So these two things that we're going to do today, you can use any time to find the answer. Factoring, what we did yesterday, cannot always find the answer. So can't always factor. Right. Okay, very good. Let's go here. So the quadratic formula, have you guys heard the story of the quadratic formula? You heard about the negative boy? Okay. So if you haven't heard about the negative boy, here it is. The negative boy couldn't decide to go to the radical party. So he decided to be square and miss out on 4 awesome chicks. And the party was over by 2 a.m. There you go. Over. Divide. There you go. So I don't know where I heard that. Somebody told me that a while ago. And I know there's a song that goes with it too. But yeah, there's a song that goes, but I don't know what it is. There's a song that goes with the quadratic. I think Christina knows it. She's going to sing it for us. Oh, okay. Okay, anyway. So that's quadratic formula. Now, some of you, when you got your answers for the problems that you were working out, may have, like one classic mistake here in the quadratic formula is sometimes people take this 2a and they think that it's underneath the radical b squared minus 4ac. It's not. That 2a is all by itself. So don't ever divide that 2a underneath the radical. All right, the plus minus, as Summer was pointing out, plus minus means you have the possibility of two answers. But you may have 0 and you may have 1. That's what plus minus is. All right, ax squared bx c, standard form. A, leading coefficient of your squared term. B, leading coefficient of your single x term. And c is your constant. So you can identify those three things and then remember the quadratic formula. How many remembered it? Yeah, a few, right? Got to have it. Got to know it. Then you can use this thing all of the time to find answers. Every single time it works. Now, back to the discriminant thing, the b squared minus 4ac. Discriminant. If b squared minus 4ac is bigger than 0, you're going to have two real answers. If b squared minus 4ac is equal to 0, you have one real answer. And if b squared minus 4ac is less than 0, then you have two imaginary answers, or complex. So you can tell a lot just by the b squared minus 4ac. And it's not square rooting, it's just b squared minus 4ac, whatever that number tells you. A lot of information. Okay, well, since we already did a few of these quadratic problems with your partner, we're not going to go through and take a look at these three, other than maybe just talk about number 3 here, the one on the bottom. But in anyone in your calculations of quadratic formula, was there some mistake that you were making that would be helpful for us to go through at least one problem, or is everybody okay? We're okay. One person gave me a thumb. Thank you for not the middle finger. Appreciate it. Are we okay? Okay, how about 3? Let's just talk through 3. Looking at 3, can I solve it right now? Can I use quadratic formula as the way it's set up, what do I want to do? I want to put 3x on the other side and make sure that I get a 0 out of this thing. So x squared plus 3x minus 5x. Make sure you just stick your polynomial in descending degree order, power 2, power 1, constant, and then you'll identify a, b, c. Because sometimes, here's what happens, sometimes the order might be switched. And people just get so in the habit of saying the first number is a, and the second number is b, and the last one is c. And that might not be the case. C is always the constant, b is always with x, or whatever the variable is. And then the a is always with the square. All right, then let's book it. Let's get to this guy. Completing the square. This is a good one. Because, again, another one of the methods for solving quadratics that will work all the time. This one in quadratic formula. But this one has a few steps that are involved. Sometimes you don't do this enough, you forget what those steps are. So what are we doing when we complete the square? We're trying to create, when we complete the square, we're trying to create a perfect square trinomial, and that's what a perfect square trinomial looks like. There's also one that looks like a squared minus 2ab plus b squared. That's also a perfect square trinomial. We're trying to create that. And in order for us to do that, sometimes we have to adjust. We have to add some constant to both sides of this equation so that we create an a squared plus 2ab or minus 2ab and then plus b squared in the form. Once we get the trinomial in the perfect square trinomial form, we're able to factor it, which is our goal. And then the reason we're factoring it is so that I can get something squared. And we know from yesterday, when you get something squared, to undo it, you just simply take a square root. Yeah, just take square root. So that's why we're doing completing the square. It's a little faster, a little bit, than quadratic formula. But again, speed, not the big deal. Some people like default quadratic formula all the time. Some people will go to this. So you're gonna see how you wind up. So before we get into them, though, let's practice finding out what would this number have to be, this magical constant c value that I'd have to stick at the end of the x squared and the x term so that I can do a factoring thing. All right, so that's what we're going to do with these first couple of problems, is find out what would that last number have to be. So here's a run-through of the process, and maybe this will sound familiar as we talk through it. First thing we do when we have completing the squares, there are the first two steps that can be swapped. They don't have to necessarily go in this order. But one of the things we do is we make sure all of our constants go to the other side of the equal sign. And then the other thing we'll do is we'll make sure our leading term is a 1. Once that happens, now we can go and try and find this constant value, the c value that we're going to have to use to create a perfect square. So here it is. We've got x squared plus 4x without the constant right now. So there's no c. And we're trying to find what that c would have to be. So how we do it is we find in the middle term, which is the b, we take half of it. This look familiar? Half of the b, and we square it, and then we add that number to both sides of the equation. B squared, or b over 2 squared to both sides. So if we're going to remember something about this part of the problem, I want to remember half of b and square. That's the thing that's going to create this extra number that we need so that I can factor and use square root problem. So there's a little example there, what we just talked about. Half 4 is 2, and we square it, we get a 4. We add 4 to both sides. End up with x squared plus 4x plus 4, which is factorable to x plus 2 squared. Again, that is the goal, to get ourselves into a binomial squared situation so that I can take the square root. So let's try and find, if we could, the constants that would have to be in play for these three examples. What would I have to do to be able to take these and make them into perfect square triangle? Let's talk through the first one together, and then we'll do 3 for you guys. 3, 4. They're a little tricky because they're odd numbers. Uh-oh. All right, so what am I going to do to find this magic number that's going to be out here? I got x squared plus 8x, and I'm going to find something out here so that I can create a binomial squared out of it. Well, the magic is the b over 2 thing. So here's our b. Take half of it, and we square it. That means 8 over 2. Oh, yeah, thank you. I wasn't paying attention to the negative sign. Very good, very good. So minus 8. So this is negative 8 over 2 squared, or negative 4 squared, or 16. So 16, now by the way, when you find this b squared over 2 thing, or b over 2 squared, you'll always be adding it to both sides of the equation. Okay? We'll always be adding because when you square a negative, you always get a positive. So that will always be plus right there. Always a plus. All right, so then I have x squared minus 8x plus 16. We can factor that. And you could go through the whole, okay, set up the X box. I can set up the X box. But here's the fastest way to figure out what goes in over here. We automatically know there's an X right there. And then whatever this sign is will be that sign. So if that's a negative b, I have a negative in my binomial. If it's positive b, I'm going to have a positive in the binomial. All right, how do I know what goes next? It's really this simple. Whatever your b over 2 value was, there it is what goes right there. Yeah, that's it. So my b over 2 was a 4. Well, it's actually technically a negative 4, so I would put x minus 4. And now I've got factored form of x squared plus, or minus 8x plus 6. And then I'd be able to square root and rock and roll on that. Piece of cake. All right, why don't you guys get, well, questions on how we came up with x minus 4 squared before you guys. Odd numbers, just because it's odd, don't freak out. Just because it's odd doesn't mean you can't divide it. I do not want you to make decimals out of this. I want you to work with fractions. All right, so try 3 and 4. Find out what am I going to have to add to those so that I create a perfect square trinomial that I can then make a binomial squared from. All right, moving on. So we know we have 3 halves squared is 10 fourths, and 7 halves is 49 fourths for these 2. So now, let's actually do some completing the square. Here it is. 6 steps. This one just has 5 because we have an A that's 1. If that leading term is something other than 1, they're going to add one more step to this. And we'll get to one of those in just a second. Look at that color-coded. Oh. Man. Mr. Rose is not here either, huh? I don't think I marked him absent.
So on these,
on those.
You're not putting this in parentheses. Let's say it,
Okay.
but let's say it is a negative 6x. I mean, negative b instead of negative 6.
No, I mean it's negative b over 2. Oh, are you talking about quadratic formula?
Yeah.
Okay, yes. If it was quadratic formula, that would be negative 6 squared, which would become 36. Yeah, we're not talking about quadratic formula.
But you don't make it negative 36?
Nope, because you're squaring a negative.
Isn't it?
No, it actually, when you square a negative, the negative is included in the parentheses. That's why it's plus. Yeah, b squared part will always be plus. All right, so here we go. So We're going to try with completing the square. We'll do this one together, then we'll take one that you guys can take a shot at by yourself. Color code it so that you can see the process, the steps. All right, here we are with our first problem. And we have an A of 1, a B of 6, and a C of -2. So the first thing that we're going to do is to move the C to the other side. We're going to only take the x's together. They're a family, and we're going to take the constants and put them on the other side. So, step 1, here we go. If the x squared plus 6x is now equal what size is that? Would you like to borrow a pencil? Okay. So we have that. And then step 2. Let me get you a pencil real quick. Somebody didn't steal my. Never fear. Boy Scout is always prepared. And I have more pencils. There you go. Ready? Nice catch. Nice catch. All right, so in red, step number 2. Stop me if you guys have questions or anything. But again, I think just I want you to watch this process here. Half the middle term. All right, we know our middle term is this 6. So I'm going to take half of that, square it, put it to both sides. So that would look like this. X squared plus 6x. We leave those still there. Now I'm going to take the half of 6, 3 halves. Why did I say 3 halves? Just 3. And we're going to square it, and I'm going to get a 9 that I add to both sides of the equation. There would be step 2. Step 3. We write the left side as a binomial square, which means you're factoring the left-hand side. And we said the quick way to factor is, it's always going to be the variable there, the squared variable, x, and the sign of b. And then what happens next is half of b. So 6 over 2 means that's going to be x plus 3 squared. Every single time. On the right-hand side now, we can combine and get an 11. Step 4, we are ready to take our square root because we have x plus 3 quantities squared. So we're going to take our square root now. So we have x plus 3 squared equal 11. We're taking the square root of both sides. When I take a square root, how many answers? 2. So I get x plus 3 is equal to plus or minus the square root of 11. Leave it. Don't make it a decimal. Good, Simon. We're ready for that right here. Now, step 5. You're a step ahead of me. So in step 5, we will then solve for x, which means move the 3 over. So now I have x plus 3 equals plus or minus the square root of 11. The 3 moves over by subtraction, and we finally get our answer of x is equal to -3 plus or minus the square root of 11. And there it is. There are your 5 steps. Yeah? Not that bad, is it? No, it's not that bad. The only thing that's bad about it is we got 5 steps. I just have to remember my steps. That's it. Get the constant to the other side. Make sure the A is a 1. Take half of the B, square it, add it to both sides. Rewrite the left-hand side as binomial squares by very easily saying the variable plus or minus b over 2. Then square root both sides. Solve for x by moving the constant to the other end. You're done. That's simple. All right. Questions for me? Before we, it's now your turn. rocking, rolling. Your turn. So here's what we have. A lot of us moved the 2. Great idea. And then we took half of the middle term. Again, half of -5 is -5/2. And I'm squaring it. So here's what I'm doing. Taking half of -5/2 and I'm squaring that. And I'm putting that on both sides. You guys didn't show that step. You went right to this. Which is good. You should go right to that. But this is how we're getting these values. All right, then here's where people are getting stuck. Well, one of the things is we need to make this -2 become a fraction that has a 4. Here's a quick way to do it. You take whatever you start with, -2, you multiply it by what you want the denominator to be, and that's what needs to show up on the top. So -8/4 is the same thing as -2. So I get x squared minus 5x plus 25/4 is equal to -8/4 plus 25/4, and that just becomes 17/4. Now we're ready to take this x squared minus 5x plus 25/4 and write it as a binomial square. So here it is. Whatever the lead variable is, shows up first. The sign of b goes next. Whatever half of b is, goes next. So half of 5 is 5/2. That's it. There's not really a whole lot of thinking involved other than, let's find half of b. That's what goes in that spot. So that's where some of us are getting stuck. Now we're undoing. Ready to undo this square root. I get plus or minus the square root of 17 over the square root of 4, which is plus or minus the square root of 17 over 2. And now my final answer, move the 5/2 over, is equal to 5/2 plus or minus the square root of 17. All right. Let's see what happens, though, when our A is not something nice, like a 1. What if it's a 2 or a 3 or a 4 or something else? Then we have to add one more step to those first 5 that we did in the example number 3. And that would be, and again, the order in which I do these steps, not super critical. I could first move the constant and then divide everything by A. Or I could start off by dividing everything by A. Either one will work. So we will go ahead and start off by dividing both sides by the A term. So what is the A in this problem? Simon, wake up. What's the A in this problem? 3. So I'm going to take everything in this problem, and I'm going to divide it all by 3. So 3 squared over 3 just becomes x squared. 9x over 3 is now 3x. 3 over 3 is 1. 0 over 3 is 0. So there's our first step lesson. So this now is x squared minus 3x plus 1 is equal to 0. Now you're ready to solve the problem just like we were with the last example. All right, let's see how quickly we can do this. Caesar, what do I do first? Add the 1 to the other side. Do I want to add the 1 to the other side? I want to subtract the 1 to the other side. All right. Next. Jen, what do I do next?
Divide -3 by 2.
Okay, divide -3 by 2. And I get what, Jen?
You square that, and it's -9/4.
Okay, but it's
Or
a
just
9/4, right? -3/2 squared is 9/4, and I add that to both sides. All right, very good. Evan, what do I do next? Okay, we need to change that, don't we? Yeah, we need to make negative 1 plus 9 over 4 a fraction thing. So what's negative 1 going to have to be? Negative 4 over 4 plus 9 over 4. So now we know that's 5 over 4. All right. We got that. X squared minus 3x plus 9 fourths is now equal to 5 fourths. All right, Bobby, what do I do next?
And you turn x squared minus 3x plus 9 fourths to x minus 9 over 4.
Oh, so close. X minus
3 over 2.
There you go. X minus 3 over 2 is equal to 5 halves. All right. Oh yeah, I said halves. Okay, good. You guys are doing great. Next, Kristen, what do we do next? Take square root of both sides. And when I do that, I get x minus 3 over 2 is now equal to plus or minus the square root of 5 over. Can we shortcut it? What can I write underneath? 2, because the square root of 4 is 2. Yes. You have to. If it's a perfect square, we're going to simplify it. And then my last thing, what do I do, Arthur?
Add 3 over 2.
And voila. Find our solution. So, it's really that first thing of moving, or not really moving, we're dividing out the A, whatever that is. Once we're done with that, you're rolling through the rest of the problem like we've been doing. Questions for me? Okay. Then you are trying it. Let's do